Today we're covering section 4.5 of your BJU Press Pre-Calculus textbook. We've been looking at inverse functions, and today we're going to take a look at inverse trigonometric functions, which are similar to the inverse functions that we've been looking at, but there's some special characteristics and qualities about them. So we're going to define inverse functions, we're going to evaluate them, and then also look at their graphs. So to remember, when we're doing the finding the rules for the inverse function, you change x and y, and then you solve for y. So when we're doing trig functions, like for example the sine function, if we have y equals sine x, and we switch x and y, we end up with x equals sine y. And if we want to solve for y, we have to do the inverse sign, so sine inverse. So we set sine inverse both sides, and then we get y equals sine inverse of x. Or y equals arc sine x, because remember arc sine means sine inverse. So this right here, y equals sine inverse x, that is saying y is the angle whose sine is x. So it's like the reverse. So like instead of solving like what is sine of an angle, you're saying what angle is this. So you're kind of working backwards. So when you're doing the inverse sign, your answer should be an angle. So let's consider the graph of a sine function. Remember, when we're doing inverses, it has to be one-to-one. So just like in the last lesson, we learned to restrict our domain so that way everything is one-to-one. So we're going to do that for our trig functions as well. So what we're going to do is, in order to make the sine function one-to-one, we're just going to look from negative pi over 2 to pi over 2. And so since we're only looking at that portion, we can now take the inverse. Okay, and so to graph the inverse, we're going to reflect it across the line y equals x. So there's the line y equals x. So we'll reflect it across that, and we end up with our sine inverse of x graph. So notice how we have the capital S on sine. Anytime you see a capital S, that means that we're looking at the sine function, but we're only considering from negative pi over 2 to pi over 2. That kind of is your cue to only look at that portion of the graph. So let's do this example. We have y equals sine inverse of 1. And we want to find y. So remember, we're trying to find an angle. So we're trying to find the sine of what angle is 1. That's what we're trying to do. Sine of what angle is 1. And remember, we're only considering from negative pi over 2 to pi over 2. So what angle between negative pi over 2 and pi over 2, if we take the sine of it, we end up with the answer 1. So we think, well, pi over 2, if we take sine of pi over 2, that's 1. Because remember, pi over 2 is 90. So sine of 90 is 1. That's y is pi over 2. Let's do another example. Let's find the sine of the sine inverse of 1/2. So this is like a function inside of a function. So you're going to want to work inside out. So before we take sine, we want to do sine inverse. Sine inverse of 1/2. So we think, okay, sine of what angle is 1/2? Well, we just said sine of pi over 6 is 1/2. So sine inverse 1/2 is pi over 6. So that means now we have sine of pi over 6. And sine of pi over 6 is 1/2. So here's like a neat little trick. If you have sine and sine inverse, like if you have the same exact function going on, and it's just going to be whatever this answer is. So that's an easy trick to know. So here's an example where it's not an easy trick. You have sine and then cosine. So again, work on the inside out. Cosine inverse. So cosine inverse of 3/4. So what angle, okay, so what angle gives us 3 over 4. So this is not a special angle. Okay, this is not a special angle because remember all of our special angles are either the square root of 2 over 2, the square root of 3 over 2, like one of those answers. So 3/4 is not. So what we're going to do is we're going to build a right triangle. So it represents an angle. And since the 3 and the 4, because remember cosine is adjacent over hypotenuse. Okay, so since 3 and 4 are both positive, that means it's in the first quadrant. Okay, so that means that we're going to have this right triangle, right? So here's the adjacent, the 3, and here's the hypotenuse, here's 4, and here's our unknown angle. So here's our triangle, right? And we want to find the sine of this. We want to find the sine of this angle. So again, we use the inside to build our triangle. All right, we use the inside to build our triangle. Now we want to take the actual operation on the outside, the sine. So we want to find the sine of this angle. So sine is opposite over hypotenuse. They didn't give us the opposite, but since we built the right triangle, now we can use the Pythagorean theorem. So we'll use the Pythagorean theorem to solve for x, and then we end up with the square root of 7. So we want to find the sine opposite over hypotenuse. That means we have the square root of 7 over 4. All right, let's do another fun one. Let's do cosine inverse negative square root of 2 over 2. So because we are negative right now, we're saying what angle gives us the square root of 2 over 2, but it has to be negative. That means we're in the second quadrant. Okay, so because remember, if it's negative, that means that our adjacent is negative, and remember, adjacent corresponds with x. So in order for the x to be negative, that means we need to be in the second quadrant. So we know that the cosine of pi over 4 is equal to the square root of 2 over 2. So in order for it to be negative, in order to get to the second quadrant, we said, well, how do we get pi over 4 in the second quadrant? Well, we do pi minus pi over 4. Because remember, it goes from 0 to 180 is the pi. So if we're looking for the second quadrant, we just subtract, we get the reference angle. So pi minus pi over 4 gives us that reference angle of 3 pi over 4. All right, go ahead and attempt some problems on your own.